Good morning students, chemistry with DNA. I am Noman Ahmed. Today the new topic is Fehling test. It is also called Fehling test. It is a test which is used to distinguish aldehyde from ketone. We also discussed another test that is also called a Fehling test. That Fehling test is also used to distinguish aldehyde from ketone, but this test is less powerful as compared to Fehling test. It is also used. So let's discuss this test. The name of this test is Fehling test. Some people call it Fehling test. Both we can say it is Fehling test and it is Fehling test. So there is no difference between the name. You can call it by any name. Now see, what is basically Fehling test? Basically, it is a reaction of, it is a mixture of two solutions. Suppose it is a mixture of two solutions. So what is the this is called solution A, and the second is solution B. If somebody asks from you what is solution A, so solution A contains copper sulfate dot 5H2O. This is solution A, and solution B contains sodium potassium tartarate, sodium potassium tartarate. You need not to remember the formula, but if somebody asks from you, you can write the formula. You should know the formula of tartaric acid, in which there is OH group is present on the second carbon and OH present on the third carbon, and C double bond O, this is sodium, and this is C double bond O potassium. So this is also called sodium potassium tartarate. Very easy. Both copper sulfate dot 5H2O and sodium potassium tartarate, collectively they are called Fehling test. So this test, what is the most important? It is used only for aldehyde. It means it is not used for ketone. It is mild oxidizing agent. This salt is also called, suppose if we just call it another, there is a Rochel's salt, we can call it Rochel's salt. This is also important, you can write it in important section. So this is the mild oxidizing agent, and we can now it can react with only aldehyde. It cannot be used. Suppose it is used to distinguish. It is used to distinguish aldehyde from ketone. And as I told you in the previous video as well, aldehyde contains C double carbonyl group, and there is only hydrogen is present with carbonyl compound, R is present, but in ketonic group both sides are attached, R is attached on carbonyl compound. So this is only used for aldehyde. So let's discuss the reaction of this. Now see, this is the reaction, how this reaction happens and how does it distinguish aldehyde from ketone. So the chemical reaction is very easy. Suppose we have any aldehyde group. Suppose this is aldehyde, and if we write the name of that is copper sulfate dot 5H2O plus NaOC double bond Now this is tartaric acid. Sodium potassium tartarate. You need not to write the whole, just take it out only copper. Now copper plus 2. Now see what will happen. In the solution, the reaction will change into like the same. Now see, this compound changes, aldehyde changes from, now see there is increase in oxidation state. So this is simply oxidation. Why? Because there is an increase in oxidation. If there is increase in oxidation, so automatically there will be reduction will be there. So copper changes into Cu2O, cuprous oxide. Now what is the oxidation state of cuprous oxide plus 1? Now from copper change, copper gains 1 electron. Now see, from plus 2 to plus 1, so it means it is a reduction automatically. Whenever there is oxidation, there is reduction. So they will form from Cu plus 2 to Cu plus 1. So what will be the color? If suppose the color of this copper is blue, so it is changes into reddish brown. Reddish brown. It means that there is a reduction, because copper plus 2 contains blue color, and when it is in cuprous oxide plus 1, it changes its color from blue to reddish brown. It means there is a reduction. And here this, like intolerant region, we discussed in the previous video as well. Intolerant region, only aldehyde changes into carboxylic acid. This CHO changes into C double bond OH. In Fehling or Fehling test, it is also changed from C double bond OH to RC double bond O negative. It means it is a test which is used to distinguish any aldehyde from ketone. This is mild oxidizing agent, but we can say that aldehyde gives only Fehling intolerant test, but ketone does not give Fehling and tolerant test. So this is easy test, you can just distinguish it. One thing very important, let's discuss it. Suppose you have two tests, that is tolerant test and Fehling test. So we can say that tolerant test is more powerful than a Fehling test. Suppose there is a reaction of benzaldehyde. So when tolerant reacts with benzaldehyde, so this benzaldehyde is changes into benzoic acid, but Fehling test does not change benzaldehyde into benzoic acid. This is benzaldehyde. This is benzoic acid. It means tolerant test is more powerful than Fehling test. Both tests are used to distinguish aldehyde from ketone. It is used for aldehyde or for ketone. So, but between these two tests, you can say that tolerant test is more powerful than a Fehling test. So this is very easy test in which we can distinguish aldehyde from ketone. And again, if there is any question in comment section, please do message me, do comment, so that we can bring innovation in that question. Take a very good care of yourself. Assalamu alaikum.